Hello everyone and welcome to Network Playroom. This is the 10th video in the Christmas calendar series, and today we're stepping away from the Sketch app and doing some labs. I'm here on INE Rack Rentals and I'll show you basic spanning tree protocol configuration and verification. I'll go over the same topics I've discussed in my previous videos, but now you'll see those topics in practice. But before I modify anything on the command line, remember the 3 steps in calculating the spanning tree topology are: number 1, selecting the root switch; number 2, finding the best path to the root switch; and number 3, blocking redundant links. So the switches are in the default configuration, so their spanning tree priority is going to be 32,768. So we'll have to look at the MAC addresses to determine which switch is going to be the root switch. So the base MAC address, which is used by the spanning tree protocol, can be viewed with the show version command. So let's issue this command on each switch. So let's go on switch 1 first and do show version. I'm gonna use the pipe command to narrow down the output to only include the line that we need. And actually, let me copy and paste this in a text editor so we can look at the MAC addresses more carefully. Okay, then switch 2, do the same thing, show version, and then include base. Let's copy and paste that. So switch 2. Oops, we'll have to go this way. And then finally switch 3. Okay, so now we have the base MAC addresses of all 3 switches. So let's see here, switch 3. So looking at this output, we should see switch 3 become the root switch because it has the lowest MAC address. However, there's a but. So I did run a few tests before recording this video, and unfortunately that's not the case. So I'm assuming what's happening is that there's actually another switch that is not displayed in this topology diagram. Maybe this is the logical topology and not the physical topology, and there's another switch somewhere that is acting as the root switch at the moment. So when I do show spanning tree output, actually let me do that on switch 3, and we'll see that it's not switch 3 itself. It's not the root switch. So as you can see here, so this first section starting here lists the information about the root switch. So you can see the MAC address of the root switch is actually 001C58F48030, whereas we've just seen that the MAC address of switch 3 is something different, and that is actually listed on this part. So this section shows you information about the local switch. But we'll change that in a moment. Let's not get into the mystery of the root switch too much right now. Let's focus on this information. So as I mentioned, the priority is 32,768 by default, and then there's the vlan-id, which makes it 32,769. And here you can see the MAC address information. And here we can look at the output on these other switches as well. Show spanning tree. So again, you can see the same root switch information, the mystery switch. We don't know where it is. Actually, some information we do know about it is that the root port is FA0/21. So the root switch is connected somewhere beyond that interface. But again, here you can see information about the local switch. It's bridge priority, then the MAC address, the hello time, max age, and forward delay, and aging time we'll look at in another video. So I'm gonna skip over those for the purposes of this video. And then finally, let's go to switch 2. The output's not gonna be much different. Okay, looks like this one's stuck. So let's not look at that. Okay, but yesterday we talked about the bridge priority and how it is used to influence the root switch selection, but the value can be configured only in increments of 4096. So let's actually test that on the command line. So if you try to insert a random number, which is not a multiple of 4096, iOS should give you an error that the value is not valid, and it should list all the available values. And these values should actually match with the table that I've included in yesterday's video, and I should have it here on my desktop. There it is. So the valid priority values should be these. But let's test that. So since switch 3 was supposed to be the root switch, let's make it the root switch by changing the bridge priority. So let me see here. So we need to go into the global configuration mode, and the command is spanning tree VLAN, because Cisco supports per VLAN spanning tree. And actually here you can see that we were looking at VLAN 1. So VLAN 1 and priority. So let's do something random like 100. Now, as you can see here, it states bridge priority must be in increments of 4096. And below that, it says the allowed values are. So there's 0, 4096, 8192, and so on and so forth. So again, if we look at this image, so the values on the right column here, they match this list. Okay, but just for the fun of it, let's use the lowest value, which is 0. There we go. So now what should happen is that the switches are going to recalculate the spanning tree topology, and switch 3 is going to be the root switch. So let's go back to the diagram quickly. So switch 3 is going to become the root switch. Now let's quickly think about what ports are going to be forwarding and which ones are going to be blocking. So we actually didn't look into which port would be selected as the root port if there are multiple links between the switches. But we'll look at that in another video in more detail once I discuss the PBDU in detail. But for now, you'll just have to trust me that it is the lowest port ID. So in this case, between switch 1 and switch 3, it would be FA0/13, And between switch 3 and switch 2, it's going to be FA0/16. So all ports on switch 3 are going to be designated forwarding because that is the case on the root switch. And on switch 1, FA0/13 is going to be the root port. And the same, not the same, FA0/16 is going to be the root port on switch 2. And then the other two ports, FA0/14 and 15 on switch 1 will be blocking. And similarly, FA0/17 and 18 will be blocking on switch 2. But now the question is, on this section here between switch 1 and switch 2, so which end is going to be designated and which is going to be blocking? Because remember, on each segment, there has to be a designated port on one end. So if you remember, in order to select the designated port, the switch must send superior PPDUs on that segment. And to determine the superior PPDU, the PPDUs are compared in the sequence which included the 4 items. And we're looking for the first occurrence of a lower value. So those 4 items are the root bridge ID, the root path cost, the sender bridge ID, and the sender port ID. So since the root bridge ID and the root path cost for switch 1 and switch 2 are the same, we'll have to look at the sender bridge ID. So now we'll have to go back to this list and see that switch 1 has the lower MAC address. So switch 1 side is going to be designated. So all of these 3 ports are going to be designated on switch 1 side and blocking on switch 2 side. So now let's verify if that is actually the case. So let's just see on switch 3 first that it's actually become the root switch. So show spanning tree. And it is. So this is the root switch. Or sorry, this bridge is the root, it says. And then if you see here, all of the ports are designated forwarding, and the cost is 19, which is the default cost for a fast Ethernet interface. And then let's go on the other switches. So now let's issue the show spanning tree command again, and we should be able to see that this side is designated. Let's see if this is accurate. So FA0/13 is the root port, and FA0/14 and 15 are both blocking. So if we go back to the diagram, so as I stated earlier, this is the root port and these 2 are blocking. Oh, and then these 3 ports should be designated. So let's see. So 10, FA0/10, 11, and 12, they are designated, just as expected. And now finally, let's look at the output on switch 2. Show spanning tree. So we can see here FA0/16 is the root port, and 17 and 18 are blocking. So just as expected as well. And then 10, 11, 12 should be blocking as well. Oh, now I'm on the wrong switch. This one. So 10, 11, 12, they're all blocking. So just as we expected, now that we've changed switch 3 as the root switch. So this is a good exercise for you to do before you configure anything or before you start verifying anything. Just make sure that you have the same idea of the spanning tree topology as the switches do. And then go on the command line and see if you were correct. And if you weren't, try to figure out why you didn't get the same result as the switches. But that's it for this video. Thank you for watching, and I'll see you in the next video.